1-1 in college algebra prep. We're starting off with a little refresher of interval notation and then talking about functions today. Let's go ahead and get started. They want us to graph these inequalities, which are just one-dimensional inequalities. So this says x is greater than or equal to 3. Remember that the greater than sign points to the right and the less than sign points to the left. So to be able to graph these on the number line, we need the critical value that this guy's talking about, which is 3. It doesn't necessarily matter where you put him. You just got to put him on there somewhere. But you do have to have a scale, so I'm going to number the rest of this. Remember, the numbers should get larger as you go to the right and smaller as you go to the left in that case. Then we will graph this on the number line. So since there is an equal to bar, we will put a dot at 3, and it needs to be a closed-in dot, meaning that is included with this guy. And all the x's that are greater than that, we'll just take our pencil and go nice and fat, and we'll make ourselves an arrow going like so. But what they ask us to do is to put this in interval notation. I do believe that you have seen interval notation before, so we have to read the graph from left to right. That's how we read things in mathematics, from left to right. And we want to know, where is this red arrow at? And as the numbers go further and further and further to the left, they go all the way to this place called negative infinity. And as they go to the right, they go to positive infinity. Well, I use this little purple guy right here. I'm going to call him my straight edge, this purple guy, to show me where this red thing is touching. And I have to start as far left as humanly possible. So as far left as possible is at negative infinity. And this red graph is not going to touch that thing at all. And if I continue to slide, it's not touching it. It's not touching it. It does not start touching it until I get to right here at 3 in that case. That means that is where my interval will start at. So I start at 3. Since it is a closed dot, that means it's included. We'll put this square bracket. And you guys have seen this before. So square bracket means it's included. If it was not included, I'd put a parenthesis. And then if I continue moving, doesn't this purple straight edge just keep touching the red thing? Keep touching. Get off there. Keep touching the red thing, keep touching the red thing, keep touching. That's going to go on forever and ever and ever. So that's going to go to positive infinity, which you make the infinity sign like this. And you can never touch infinity, so you always get a parenthesis with that. So that interval, read out loud, is 3 included to infinity. If we was to graph another one, where x is less than 5, we've got to have 5 on our number line. We'll go ahead and put our scale. Then I've got to put a dot at 5. Since it's not included, that's going to be an open dot. And all the numbers that are less than 5 are going this direction. So we'll put a cool arrowhead on there. It's all nice and fat so I can see it. And then to read that interval, I use my cool little straight edge here. Would this blue thing, which is over here at, would the blue arrow run into my purple straight edge way over here at negative infinity? Well, yes, it would, because there's an arrowhead going on there, and that's going to go on forever and ever and ever. So our interval actually starts at negative infinity, and you always put a parenthesis with negative infinity. And as I move to the right, the purple thing's touching the blue guy. He's touching, touching, touching. If I could grab the right thing. Come on, don't do that for me. There we go. Touching, 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 all the way until I get to 5. 5 is a critical value, and since there is an open dot there, 5 is not included, which means we get a parenthesis. And as you can see, as I move this purple thing further and further and further and further, it's not touching the blue guy, not touching, not touching. There was no more touching, so that was the only interval that had. Both of these had one boundary involved with them. You notice geometrically they look like rays, which only have one endpoint and go on forever in another direction. This dude right here has 2 boundaries. He's a compound inequality. It says x is greater than or equal to -1, and at the same time x is less than or equal to 2. So I need both of these critical values. I always start with the smaller one and see if I can make it counting by 1. So if I had a 0 and a 1 and a 2, you bet I could make it. But we're going to finish what we started and finish our scale. Then at these critical values, you just go put your dot. This -1 deals with this little symbol right here, so he has an equal to bar, so he will have a closed dot. This 2 deals with this symbol right here. He also has an equal to dot, and it's every number in between them. Because this guy read x has to be greater than -1, bing, and at the same time less than 2. So that's going to work. If I use my little straight edge test, not touching, not touching, not touching until I get to -1. So -1 is where my interval starts, and he is included. Thank you, close dot. And then as I keep on moving to the right, it's touching, touching, touching. Everything in there is touching, touching, touching. All of a sudden, boom, it's going to stop. There's no more touching of the blue thing over here. So it stops at 2, and that is also included. And that's where the numbers are between -1 and 2 included. So this is very much the same thing. This looks like a segment because it had 2 boundaries. This is going to look like it's a segment because it has 2 boundaries. -2 to 3. Let's see if we can make it count by ones. I'd go to -1, then the 0, then the 1, and a 2 to 3. Whew, just barely made it. If I didn't make it, I'd have to change the scale. But this -2, he gets an open dot due to the fact that there's no equal to bar here. And the 3, he gets him a closed dot. And this is all the numbers in between. So nice and fat with the pencil. And as we read this guy from left to right, this little straight edge test, I use him a lot. No touchy, no touchy, no touchy, no touchy, no touchy. It's actually still not touching here at -2 until I move just a little bit to the right of it. So that's why when we write this down, -2 is not included. He didn't actually count as being touched by the blue thing, but then it was touching, 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 touching. It's going to keep touching until I get to 3, and it actually is touching it at 3. Thank you, close dot. And then as we move to the right, there's no more touching. That thing's going to run out. So the last one again is how the heck do you graph all real numbers on a number line? It's like, well, how do you know where to start? It doesn't matter where you start. You can pick any number you want to. I'm just going to start with 0 and put myself a scale. And if I need to graph all real numbers, bro, that's everything. It's all of them. So any number possible. It's going to go on forever this way, and it's going to go on forever that way. And check out what happens when we do our little straight edge test to find that interval. Like the purple thing is touching the blue guy because it's going on forever and ever and ever. It's touching, it's touching, it's touching, it's touching the blue thing, it's touching that blue thing. It's going to keep on touching. Even if I go this way, it was always touching. So where was it touching at? It started way over here at -infinity. It was touching, and it went on to +infinity. And I know you've seen it before. That's how we say all real numbers in interval notation from -infinity to +infinity. So that was a cool little refresher. Also, functions. We've talked about those before in your math classes in the past. What is the definition of a function? Well, it's a correspondence in which every element of the domain maps exactly to one element of the range. And let's refresh our memory on what domain and range is again. The domain is the set of all possible x values. So if you need to pause the video at this point to write that down, you can. And the range is the set of all the possible y values. A function could be a relation or a table of values, a mapping, or a graph. So let's kind of go over what those look like. If you had a relation is just a set of ordered pairs. So I got 2 different sets here. I got like set A and set B, or green set and blue set. These are functions because every element of the domain, which is the x's, let me get my cool little highlighter. See all these x's, 1, 2, and 3. He just maps to one little partner. Or in our own words, the x's don't repeat themselves. Here's a 1, you don't see a 1 again. This is a 2, you don't see 2 again. This is a 3. There's no what I call repeaters in the x's. And that's all that we care about is the x values. Look at this guy. The x values, 4, 5, and 6, no repeaters. Even though these y values, the range dudes, totally repeat each other, that doesn't matter to be a function. It's all about the x's. And do you see any repeaters? Like over here, this is not a function because you see bing, bing. 2 repeats itself. 2 came to the party with 6, and 2 also came to the party with 4. That's not a function in that case. It's like if you went to a candy machine and you hit the 2 button. It's like if you hit a Snickers, only one Snickers should pop out. If you hit the button and a Snickers and Doritos come out, that doesn't work. That's not functioning. That's not how the candy machine is supposed to function. So it's not a function because the x has repeated itself. How would we say this out loud? The element 2 in the domain maps to more than one element in the range. We'll see more of that later. That was as a relation, just a set of ordered pairs. If you had a table of values, you're looking at the same thing. Look at your x's, 3, 7, 9, 20. Nothing repeats itself. That's a function. But over here, nope, -1 is shown up in the domain more than once, and they partnered to somebody different. So the element -1 in the domain maps to more than one element in the range. And as a mapping, that's those cool little bubbles with the arrows. You can see that it's all about these guys. There's no repeaters in the domain, and they all have one arrowhead coming off of them. That means that they just map to one guy. That's awesome. You can see here, like 2 maps to 6, 3 maps to 7, 4 maps to 6, and 5 maps to 8. It doesn't matter over here. It doesn't matter if more than one arrowhead goes to 6. It's about these guys. Is one element in the domain just mapping off of it? One arrowhead, so that's a function. But do you see how 8's the bad guy over here? This is not a function because 8 has 2 arrowheads off of it. He's going to 2 different things. That's not a function. So let's try some stuff. In the following relation, that's a set of ordered pairs, find the domain in range. Well, it depends on if you're what's called a discrete situation or a continuous. And discrete is just made up of dots or points. You know, here's 3 different points. The domain is so simple. We're going to put them in these fancy schmancy little set brackets right here. And the domain is all the x values. And you don't get to list anybody more than once. So 1 is in the domain, 6 is in the domain, and 3 is in the domain. Do you see how those were all the x values? If there was a number in there more than once, you don't list them in the set more than once. You just put them in there once. And I don't care if you want to put these in numerical order or not. I think that's kind of difficult. I'd rather just go in the order that they're listed. Find the range. Well, the range is simple. It's the set of the y values, but you don't list anybody more than once. So I got 2 in there, I got 4 in there, and I got 5 in there. And you see how nobody repeated itself. So this was a relation because it's a set of ordered pairs. Is it a function? Yes, it is, because no repeaters in there. Every element in the domain maps to one element in the range. So let's try a few more. When they ask if a graph is a function, you could use the vertical line test, which I think you have seen before also. So if I was to get myself a cool little vertical line going on here, if I was to draw a vertical line that went through this graph, here's how the vertical line test works to refresh our memory. Is if the green line that I just drew touches the graph in one spot, that's fine, that's good. But he can't touch it in more than one spot. So do you see how this green line touched the graph in one spot? Let me draw another one. What if I drew this green line? Does he touch the graph in one spot only? Yes, so that's good. What if I drew this vertical line? Remember, I got to draw vertical lines. You know, people are like, well, why if you drew that line? Well, that's a horizontal line. We're not doing that. We're doing the vertical line test. So no matter where I draw a vertical line through these graphs, it's going to touch it in one place. That means it's a function. Every element in the domain maps to one element of the range. So we will say, yes, this is a function. Now the new question is he discrete or continuous? Discrete means there was just a bunch of dots, you know, just some points random. Continuous means they like connected it together and made a graph. So this guy is continuous. And when we have continuous functions, we try to list their domain and range in interval notation. How do we do the interval notation? We go from left to right for domain, just like we were doing on our first few problems. And then range is about your y values. Don't they have to go low to high? The y-axis goes up and down. So let's do domain first. Here's my little straight edge, and I want to know if I put this thing way over here at negative infinity. See, here's -1, -2, -3, -4, -5, -6. It kept going to negative infinity. Would this graph, which does go on, I say that's what the arrowhead means, and I know your paper might not have the arrowheads on there. Sorry about that, but they're supposed to. Would this graph, which does keep getting wider and wider and wider and wider as I go to the left, eventually run into that purple thing? The answer is yes. It's going to keep going on forever. And even though it's going up, it's also getting further and further to the left. So my domain starts at negative infinity, because if I kept going further and further, that thing is going to run into it. Then let's just keep moving on. As I move to the right, is the purple thing still touching the red guy? Yep, he's still touching, still touching. Don't do this to me. Still touching. Yep, still touching, still touching, still touching. And even if I go over here, remember this thing's going to get wider and wider and wider and wider. It's going to touch, no matter how far left and right I go, that thing's going to go from negative infinity to positive infinity. Now, that can be a very difficult thing for people to see. If you have trouble with that, please let me know and we will work together and I will help you with that. But that's domain. Domain goes left to right. We usually get pretty good at domain. It's this range thing. Range can't go left to right. Range is about the y values, and we have to go up and down. And we'll always start at the bottom because we got to go low to high. And here's the crazy thing. Will this graph run into this purple guy, which is down here at negative infinity? And the answer is no. This red graph does not run into this guy. It's got this minimum point right here, which we don't even know where it is. What a weird graph. So here's -1, -2, -3, -4, -5. It's somewhere between -4 and -5. So I'm going to call that about, since I'm guessing, -4.2. I don't know. I'm just guessing. But he is included because there's not an open dot there. The only way you'd put the, included means you put the bracket. So only way you put a parentheses if there was an open dot there. They're all closed in. So that's where this graph actually starts touching. It's not touching, not touching, not touching. It starts touching at that -4.2. Okay, and then if I go higher, yep, it's touching. The purple thing's touching the red graph. He's touching, 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 and then remember those arrowhead means it's going to keep going on forever. So this higher that I get, it's going to keep on touching. So that's going to go up to positive infinity on the y-axis. From the y-axis, that thing went from -4.2-ish approximately all the way up to infinity. Weird. So that's a lot. Let's try this guy. They want to know, is this graph, which is a circle, a function? How do you tell if it's a function? We're going to use the vertical line test. If I draw a vertical line that goes through there in more than one spot, it is not a function. So this is a big fat no. Now some people ask, well, what if you drew this vertical line? It doesn't touch it at all. Well, I get you. The question is, can you draw a vertical line that goes through the graph in more than one spot? And the answer is yes, I can. So since I could draw that vertical line, that is not a function. We can still answer these questions, though. Is it discrete or continuous? Discrete means it's just a bunch of dots. They didn't connect them together. Continuous means, yep, they connected them all together. So this is continuous. Now let's do the old domain and range with my cool little purple thing. So for domain, I got to have this thing going up and down because I want to go left to right. And I want to know, if I put this thing way over here at negative infinity, will it run into this red circle? And over here, this red circle is not touching that purple thing at all. It doesn't have like an arrowhead that says, yo, bro, I'm going on forever. If I keep going over here, that red circle does not touch the purple thing. It doesn't touch the purple thing until I get right about here, which is at -1 on the x-axis. And since it's not an open dot, it is included. And if I move it a little further, yep, that red circle's touching the purple thing. Yep, it's touching. That's all I care about is where is it touching. So let's do this. Yep, it's touching. Come on. It's touching. This is a lot easier in person. I use a straight edge. Touching, touching. Even right there it's still touching, but as soon as I get over here, it's not touching anymore. So there was an end point, and it stopped touching at 5, which is also included. Do you see how it went from -1 to 5? Now when we do the range has to go low to high, so I have to think of my little straight edge to do something like this. So I'm going to put her right here, get her a little more square, and I'm going to, wow. So check out my little purple thing. Is the red circle running into the purple thing if I go way down here at negative infinity? And the answer is no, it's not. I'm going to keep bringing it up until it starts touching the red circle. And there it is, and there's -5. At -6 is where it starts touching, included, because there was no open dots. Then if I keep going up, yep, red thing's touching the purple guy, touching the purple guy, touching the purple guy, touching the purple guy. No longer touching the purple guy, and it stopped at 0. Remember, we care about the y values now. People are like, well, isn't that at 2? It's like, yes, that's the x value. Yes, it is. But we care about, since we're doing range, we care about where this thing runs into the y-axis at. So it went from -6 to 0, also included, because that was a closed dot. So remember, for range, we're doing y's. So one more of these. We just got a couple more left. Is it a function? Well, let's try the vertical line test. If I draw a vertical line, does it just touch the graph in one spot right there? Yes, it does. One spot? Yes, it does. Anywhere that I draw a vertical line, that thing's going to touch in one spot. Sorry about that, guys. So that's great. This thing will pass the vertical line test. So is he a function? That's a yes. Is he discrete or continuous? Notice how they connected all the dots together, so that is what's called continuous. And then let's do domain and range. The domain, we got to go from left to right. Make this thing longer too, so we can get up here and all the way down there. Go from left to right, and you see this arrowhead? This arrowhead is the key. I know your paper might not have it. I need to just tell you in class that there is an arrowhead. This thing is going to keep going down and to the left, down and to the left, and I'm just going to overextend it so I can kind of make my point here. And that actually will run into this purple guy eventually somewhere, because this thing's going to keep going left and left and left and left and left and left. It will run into that way over there at negative infinity. Remember, you always put parentheses with infinities. So then as I move, the purple thing touches, touches, touches. It's just got to touch the red graph somewhere, touches, and the same thing's going to happen up top to where that thing just keeps moving higher and higher and higher. Stop it. So awesome sauce. That's going to go, it's going to run into it, it's going to keep getting higher and higher and higher, but it's also going to move further to the right, so that's going to go to positive infinity. Then when it comes to the range, I got to flip this guy to the side and go low to high. The range is actually a little easier to see on this guy. Thank you, arrowheads. This guy, will it run into the purple thing way down here at negative infinity? It sure will. It goes low forever. So negative infinity, that is a parenthesis. My handwriting's just not that good right there. And then as I go higher, it's going to touch the red thing, touch the red thing. Come on, touch the red thing, touch the red thing, touch the red thing. It's touching, 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 touching. That's going to go up forever and ever and ever, and it's going to run into it. So all reals again. So just a couple more. Here's a weird guy, a piecewise graph, which you made in Algebra 2 because it's two different pieces. You got your green piece, you got your red piece. Is it a function? Well, let's try the vertical line test. Here's the old vertical lines. Does it just touch the graph in one spot? Yes, it does. Does this touch the graph in one spot? Yes, it does. Does this touch the graph in one spot? Yes, it does. Even if I do this, well, it didn't touch it in more than one spot, so that's okay. Is if you can draw a vertical line that goes through this graph in more than one spot, then that is not a function. But this guy, it is a function because it passes the vertical line test. Is he discrete or continuous? This is continuous because they connected all the dots together. And then the domain and range, ooh, this is going to be fun. So let's check this out. If I take my straight edge, first of all, will this green thing run into it? I'm going to do this. Will this green thing run into this guy at negative? Well, the arrowhead means, yo, bro, we're going down forever. So look, that thing is going to run into that dude. Totally going to happen way over there at negative infinity. Thank you, arrowhead. But as we move to the right, is this touching? I don't care what piece, if it's the green or the red. Is the purple thing touching? Yeah, it's the green. It's touching the green. It's touching the green. Touching the green, it's touching the green, it's touching the green, and even right here, boom, there is a closed dot there, if you can kind of see that if I move this out of the way. Is it touching the green thing? The answer is yes. Yes, it is touching the green thing. Where's that at? That's at 4. Here's 1, 2, 3, 4 is what we care about since we're doing x values. So it was touching there, and if I move to the right a little bit anymore, oh no. Now the purple thing isn't touching the green guy, and it's not touching the red guy, so my domain had to stop at 4, and since there was a closed dot, we will include it. But you can definitely see there's more to this graph over here. That's why it's piecewise. It's in different pieces. It starts over again right here at 6 with an open dot. Can you see that open dot right there? There's a 6. So we're going to have to bridge the gap with the union symbol. Starts at 6, and since it was an open dot, it gets a parenthesis. And as I move on over, that thing is touching the red, touching, 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 and that's going to go on forever. Thank you, arrowhead. So that's going to go on to positive infinity. So that was the domain from negative infinity to 4 included, union 6 not included to infinity. Then the range, we got to go low to high. So we will go like so. And as low as I can get, that green thing is going to run into it way down here. So we can start at negative infinity. And then I'm going to move this guy up, and you tell me if he's just touching or not touching. I don't care if it's touching the green piece, the red piece, or even both pieces. Well, he's still touching the green one, because remember the green one goes down forever. And he's still touching the green one, touching the green one, touching the green one. Now he's touching the red and the green, which is fine. He's touching the green and red. Uh-oh, lost the green one, but he's touching the red, touching the red, touching the red, touching the red. Remember, that goes up forever. And he's just still going to keep touching the red, so that went on forever. It was always touching low to high, the green or the red or both of them. Last one, finally. Well, I guess it's not the last one. There's one more, but last graph. Is this the function? Well, you can tell with the vertical line test. I'm going to draw all the vertical lines. This vertical line does go through the graph. If I draw it a little bit better, let me do that for you right here. And how many places does he touch? Once or more than once? The answer is once. It goes through that right there. What if I drew this vertical line? He goes through the graph, even though the graph is nothing but dots. How many times does he touch the graph? Once or more than once? That's more than once. That is not a function. So that graph failed the vertical line test because of these two dudes right here. Is he discrete or continuous? Well, now you can see what I'm talking about with this discrete thing. See how it's nothing but just points all over the place, just dots. Discrete means dots. So that's discrete. When you have a discrete graph, you don't get to do your domain and range in interval notation. You just list all your x values, you list all your y values like we did before. You see this ordered pair right here is 1, 6, and this is 3, 5, and etc., where all these ordered pairs are. We're just going to list the x values, and you can just kind of trace them down to the x-axis. 1 is in the domain. 3 is in the domain more than once. We're not going to list him in here more than once. You just list him once. 5 is in the domain. And 7. Do you see how those are the x values of all of these ordered pairs? And I put them in the fancy schmancy set brackets. The range is all of your y values, so that's these numbers looking across on all of these. So there's a y value of 6 right there. There's a y value of 5, y value of 4, y value of 3, and a y value of 2. And this is not a function because 3 repeated itself in that case. So, and that'll lead us to the very, very last one is, here's a table. Is it a function? I like these questions because they're easy cheesy. How do you tell if a table is a function? You look at the x's to see if anything repeats itself. -2. Yep, 0, bingo, not happening. So what do you think? Yes or no? Is this a function? The answer is no. But if you say no, you got to say why. If you say yes, you just list the domain and range. Since it was nothing but points, you would list the domain and range like this. If we did say yes, you'd list all your x's, list all your y's. But we said no, so here's what we'll write. This is not a function because the element 0 in the domain maps to more than one element in the range. That's how you'll have to write it on our test. That's how we'll write it right here when you say no to these. So if you need to pause the video to write that down, please do so. But thanks for watching. Let me know if you have any questions. This was 1-1. Have a good one.